Well, hello. Welcome to another episode of Fun with Physics. This is your host, Mr. Easley. Oops. There we go. So today we're looking at problem set and calculator pad, problem set K12 question 2. This one is a little bit difficult to first wrap your mind around and try to think about it. It's definitely helpful to draw a picture about what's going on. And so it says that a blue car passes a red car, and it gives us some speeds or velocities in miles per hour. Then it gives us a hint right here to use meters and hours to seconds to convert this. So we have a very fancy smancy red car and a blue car, and I will show you right here doing some dimensional analysis where you end up with 57.9 miles per hour would convert to 25.88 meters per second. We could show those units canceling there. It's always a good idea. We're left with meters per second, which is in fact what we have. So the red car is traveling at 25.88 meters per second. Using the same conversion process, we'll find that the blue car is traveling at 6.63 meters per second. It is incredibly important to get these units into SI units from the beginning. It's almost always the best way to go because you can do your calculations easier with less complications. So get those units into SI units before you start. So we have the red car and the blue car. The blue car is staying constant. Its velocity does not change. It's staying constant throughout the trip. So this does not change in the scenario. But then the red car, what happens is the red car sees a stopped car, slams on his brakes, and he's coming up faster, of course. The red car is passing. You see he's going a lot faster. As he's passing the blue car, at some point, he sees something up ahead. He slams on his brakes, and he starts to slow down. So you can see right here, it says slow down to a stop, losing 4.77 meters for every second. So one thing that's going to tell us is that the acceleration of the red car is negative 4.77 meters per second. Per second. Now, all this negative sign is it's telling us that the acceleration is happening in that direction on the red car. And ultimately what the question is the red car is going to come flying past, start slowing down, and eventually the blue car is kind of like the turtle. It's going to eventually catch up again. So the tricky thing about this is you have two different things happening. At some point they are going to meet and there is a relationship and when they come together. But how exactly do we solve that? And the starting point of this, and probably the most important thing, is we have to come to two conclusions, and that is to realize that the time that is going to be spent on the red car until it passes the blue car is identical to the time of the blue car. So obviously we're trying to figure out when are they going to meet again. The times for each of them would be the same. Likewise, the distances traveled for each of them would be the same. So he's just passing the car, slams on his brake. How long until they meet? How much time in seconds passes before they're side by side again? The time would be the same, and the distance traveled by both cars would also be the same because it's passing, and then he flashes, the red car goes ahead, and eventually the blue car is going to catch up. And so when they come together, those distances would in fact be the same. And that's where we're going to start thinking about our equations and what we can use there. So when you start trying to put in what you do have, what I do have is not quite enough room on this screen. So for the velocity initial of the blue